Hey guys, my name is Benjamin Salmon. I'm one of the co-founders at DigitalSalmon, and today I want to talk to you guys about the DigitalSalmon core libraries, which we use in Unity all the time. Usually these videos will be a tutorial on how to use one of our Unity store asset store packages, but we kind of felt like doing something a little bit different and maybe starting a bit of a discussion. So what we're going to show you is our Visual Studio project, which contains a whole load of code that we bring into every Unity project that we make. It really speeds up our production process, and it's got a bunch of really nice little features in there that we use all the time. Part of the reason for doing this is we feel like there's a lot of tutorials out there for beginners if you're just kind of starting out or if you're just learning C#, but there's a real kind of lack of the intermediate to advanced level stuff, which you can really get your teeth into, and we find it really interesting. Outside of things like GDC and other kind of conferences. If you like what you see, it would be really cool to kind of hear back from you guys and get a bit of a discussion started. If we did something wrong or you got some rubbish code or you don't like something that you've seen, that's absolutely fine too. These libraries are ever evolving. We'd love to improve them and obviously give you guys credit where possible. And if you see a piece of code that you find interesting and you want to know a little bit more about, again, let me know. We're probably going to look at doing another video or two kind of on this topic at least. We didn't even get into any of the deep editor stuff, and we didn't get into any of the shader side of things. But it's kind of a matter of, obviously this stuff takes time, so if people are interested, we'll do it. And if they're not, okay, we'll let it lie and we'll move on and do other things with our time. Okay, let's jump in. Libraries is just the folder that we use when we have any third-party assets, and we consider our core libraries to be effectively a third-party asset, and we treat it as such, and we make sure it's always in a workable condition. DigitalSalmon is obviously our company name, so if we have other tools, we may put them in this folder, and then core is our core libraries. The main powerhouse behind the core libraries is a plugins directory with a couple of DLLs and an editor directory with a few DLLs in that. Some of our code comes in as C# scripts, and some of our core libraries isn't code, but it might be the CG inks for the shaders, some core fonts, some icons, or some shaders that might get used by UI or other systems. But as I say, most of the work gets done in the plugins directory in the DLLs. We keep our core libraries in the DLLs because, at least as far as Unity 2017 is concerned, you can't yet individually push your code into different assemblies. So when you recompile your code, the entire assembly for C# first pass and C# main pass gets compiled in its entirety, which obviously takes a little bit longer if you've also got code, especially code that gets brought in every time and never gets changed. It seems like a waste of time. So we like to package our code up in a DLL. So if I navigate to our core libraries, you can see here that what we actually have in the DigitalSalmon core folder is one Visual Studio solution and a bunch of different projects. So here we have the CS project for core editor. We also have our own compiled version of full serializer, but obviously, people have different preferences as far as serialization goes. We do have a serialization project, which is used to locate serializers of different types and convert between Unity objects, native objects, and JSON. We have a raw library. That's effectively a CS project that doesn't get compiled, but does get stored with the project, and we'll get into that later. And we have a library project, and that just contains a bunch of code that isn't necessarily production ready, but that exists in other projects that we didn't really want to delete because one day we may want to pull it out. There's also an assets directory. An assets directory, as I'll show you later, is an exact copy of what would end up in your new project, and that is used in the the post-build options in Visual Studio to copy all the DLLs to the relevant folders. So let's jump into the solution and take a look. So if we open up the DigitalSalmon core libraries solution in Visual Studio, you'll see here that there are those projects we mentioned earlier. For anyone who doesn't know, a solution can contain multiple projects. It can also reference other projects external to itself. And each of the projects basically comes with a bunch of references. They can all depend on each other, but you can't have cyclic dependency, and they can depend on Unity Engine and Unity Editor, and actually in the later versions, various modules of the Unity Editor and Unity Engine, in order to use Unity code in the DLL. So this code is not part of a Unity Visual Studio project. It exists outside of Unity. It could be used without Unity, providing that we took away the Unity Engine references and then fixed all of the compiler errors that we would get. So we're kind of taking C# in its kind of purest form here. outside of the engine itself. The two main ones that we want to talk about, and there's varying levels of detail we'll go into here, are the Digital Salmon Core and the Digital Salmon Core Editor. And what I'd like to do is basically talk through a bunch of the different types that we have in here and kind of talk about the justifications for some of the decisions being made and maybe some suggestions what could be improved, and basically talk to you guys about what you might want to include in your core libraries. So something that people have made a case for before, and something that I think makes a lot of sense, is that you create your own monobehavior derived base class. This is the base class that you will inherit from with all of your scripts that will go into your Unity project. And basically what it lets you do is extend monobehavior with your own functionality. So the first thing that we're doing is taking a look at all of the, at least the most used monobehavior protected fields, and we're creating our own implementation using the new keyword, which manages itself in the way that we want to manage it. So there are a few in here that perhaps don't exist natively on monobehavior. So the Rect transform and animator, for instance, are two that we use quite a lot, but that natively don't exist on the monobehavior. And what we're doing here is we're using a lazy loaded property, in this case with an expression body, and rather than simply getting component, we're calling this locate component, and locate component does in fact call the get component, but if it doesn't find it, and we have this virtual bool property here set to true, then we'll find our component on our child. Now that wouldn't be very useful in some cases, but in things like your renderer or perhaps your audio source or an animator, there can be use cases for that. Now if things are getting a bit complicated, then we wouldn't suggest using these. You should be getting component yourself on the component on the script that you're writing, but in really basic simple situations it's quite useful to do that. You'll see here that we've got an override for shared material, materials, and source materials, and all of those. We basically have a system called a material instance handler, which we're using to manage our materials and create instances of them in clones. So you might have noticed if you ever call renderer.material.setColor or setFloat or something, then you'll find that you create a clone of that instance. A clone of that material, which is effectively an instance. We want a little bit more control over when we did that and whether we did that, because using just a bunch of properties that may or may not create clones can be a little bit confusing. The other one we've added here is source material and source materials. When called in editor, what this will do is give you the editor version of the material, even if your shared material is an instance. So if you create a clone of something and then assign it to a shared material, then you've now natively in Unity, you've lost the reference to the project version. Source material will try and locate that. Okay. The other one that you might not recognize in here is Sequence. Sequence is a system that was developed by Apache Interactive, and it basically is used to control coroutines and kind of semi-asynchronous operations. We'll talk about it a little bit later, but it's kind of their IP, so I wouldn't want to go too deep on that one. The first one, which I would recommend that absolutely everyone do, is create your own colors class. So if you're ever defining a color in your code, so I'll just jump into base behavior, find a method and call color dot. You'll notice that they have a bunch of static colors ready to go. And they've got kind of the main ones, blue, green, yellow, primary, secondaries. We wanted a little bit more control over that. So we've got colors for basically a bunch of grayscales between black and white. We've got the Unity colors that are used in the Unity editor, so sort of the background gray and the background light gray. Then we've got a bunch of common colors that we just happen to use quite often, like a nice blue or a dull blue or whatever it might be, and that can be used for gizmos and for UI elements and things like that. And then we quite often, this is quite a common pattern, is that we have a partial class for colors and we have different sections of it. So colors.digitalsalmon, still in the colors class, you access it in exactly the same way, colors dot. But in our case, we have some of our brand colors in here, and we really recommend that if you're doing a project, especially for a brand, if you do a lot of the kind of interactive side of things rather than games, you may have a colors dot, Sony, or colors dot Ubisoft, or whatever it might be, and you can have all the brand colors in there. And that gives you really quick access to that exact red or pink or green or whatever it might be. Okay, cool. The extra one, we have subheader attribute. It's basically like a header, but it's a subheader. That can be really useful. People like to have quite pretty inspectors. And again, you know, something like Odin might give you a whole lot more control over this, but we like the quite basic stuff. So we're just going to go with subheader for now. We've got decorators. Okay, this is a useful one. It plugs into our UI system down the line and some of the serialization bits and the object inspector bits, but we aren't quite onto them yet. But basically, we need the ability to use a header, you know, a subheader and a tooltip on properties. So out of the box, Unity, they really should change this. A header attribute can only be given to a field and not a property. Well, given that we do a lot of our own custom serialization, including serialization of properties using full serializer and other systems, we need to be able to put headers and titles and things onto those properties and not get compiler errors. So we use the title attribute instead of header, subtitle instead of subheader, and description instead of tooltip. It's quite useful that those names weren't already being used because it meant we could use them. As well as colors, the second super important thing we would recommend you put into any of your core libraries is a set of extensions. Now this can be an extensive set of extensions if you've got many of them or you've pulled them from various places, or you know, if you use a lot of extension methods. Extension methods are a way of extending classes, giving them extra functionality. And believe me, a lot of classes in the Unity namespace and even in the native namespaces could do with a bit of extending. So first case is color extensions. We have various casting options, so you can push to a vector 4. You can lerp between an array of colors. That's quite useful. Move between colors. There's a couple of conversions between sort of string versions of colors and hexadecimal and that sort of thing. We have powers. You can normalize them. You can go between HSV, HSL, HSB, whatever else. This is a pattern that we use quite a lot, and it's quite powerful. It works on many different types. When you're working with structs and you're doing an extension method, it is a pattern that I think John Skeet is a big advocate for. We really should be naming the methods with and then some property. So if I said set alpha here, then it would be very confusing when you wrote your code and you wrote color equals blue, and then you said, my color equals blue, and you said my color dot set alpha. You would think that you'd changed the original declaration, whereas actually, since it's a struct, you are changing a copy. So we use the term with, so that when we use these things, we would be defining this as sort of color mycol equals color red or color black, and then mycol equals mycol. I'm trying to type over a microphone. Dot with, and I could set with alpha 0.2, and that's kind of pretty clear what's going on there. Oh my goodness, trying to type over a microphone is a bad time. So that with alpha one is actually especially useful. This one I use quite a lot. With red, with green, with blue, they just exist because the alpha exists, and it's good to be thorough. And then with component can be quite useful. So you pass in the enum. In this case, it's a flags enum, so you can set, you know, red and green in one to a value using an extension method. And then trim is an internal method used by something else. We also have directory info extensions to find if you're a subdirectory or a parent directory. We have enum extensions. I think this one was actually pulled from Stack Overflow. Yeah, I wouldn't want to take any credit for any of these. In fact, it's worth noting that in a lot of cases, these bits of code are taken from other places. We're not claiming they're all original. We've just compiled them into our own libraries. So we have a bunch of flag setters and getters and checking and any and all the rest of it, which can just make working with flags a little bit easier. Float extensions. We have a round method that rounds to the nearest increment. That can be quite useful. Graphics extensions. Find if a texture is readable. What's this? Return. Find the size of a texture as a vector2 int. Because quite often it comes back as a vector2, and vector2 int is kind of a new useful type. Render texture to texture 2D, that's incredibly useful, use that a lot. There's a couple of system drawing types like bitmap, but we can use that to do encoding to other image formats that maybe Unity doesn't natively support. Rendering a sprite to a texture 2D, that's quite common, and flood filling a texture with a particular color, do that every so often. There's a bunch of link extensions here. Again, some of them are ours, some of them aren't. Add if unique, shuffle. Random or default is one that we use a whole lot. So you could have a collection of any type and you could just call .random or default, and that'll just give you a random element in there. In fact, here you can see that we've used the work of other people who are much smarter than us but just kind of brought it into a nice library. Moving elements around, examining an element, converting, prepending, appending, prepending if with conditions, and all sorts of bits. What else we got in here? Filtering, is null or empty, populate, that kind of stuff. Populate's quite nice, just fills something with a particular item. List extensions, you can set the length of a list. That can be quite useful. Fills it with empty, I think. Yeah, it fills it with a default. Material extensions. Here's a really good one. This should exist anyway in Unity. It's ridiculous that it doesn't. When you call material.setFloat or setBuffer or setColor or whatever, they're all different method names for all different parameter types. Well, the compiler knows the parameter type you're handing in. You know, I'm handing in a float or a compute buffer or a color array or whatever it might be. So there's really no reason that you shouldn't just have one method on material called setProperty with a bunch of different overloads for all the different types of things you might want to set. If I set something with a property name and the property name doesn't match the type, you know, if I say setInt and then the property name is base color and that is of type color, you're going to get an error, but that's going to happen anyway because I could have called setInt manually and, you know, been mistaken in the first place. So I don't think there's really much of a case not to just have this natively in Unity. So, you know, if you guys want to add that, that would be great. Rect extensions. This one I use all the time in UI, all the time. Again, we're using this with notation because Rect is a struct, with size, with width, with position, with X, with offsets, with paddings, with clips. So we've got clip and trim, which is effectively anchored on a particular side. I either want to set the size or I want to push in or out from an edge. Splitting, these ones are cool. I don't think we wrote these, but we found these in somebody else's code, I guess. It splits a rect into a certain count and returns you the rect at a particular index. That's incredibly useful. Fit and fill aspect, these ones were ours. These were useful for fitting a rect within a rect using, or filling a rect within a rect using a specific aspect ratio. Absolute, just make sure everything's positive because rects can have a negative width. Centering to width, center to size, rounding position. With zero and with zero size and with zero position is very, very useful. All of those probably get used on a pretty daily basis, especially when you're writing editor tools and that kind of stuff. If you're working with the internal GUI system. Fairly confident that that system is getting overhauled. I think I've seen things in the Unity pipeline, so the odds of this becoming obsolete in the future, you know, relatively high. But in the meantime, you know, we don't have that system, so this stuff's really useful to have. String extensions with ellipsis trim. If a string is longer than a particular given length, then we cut it and we stick a ... at the end and, you know, fit it within that length. Does it contain something? We've got a bunch of conversions between sort of camel case, Pascal case, caps case. That kind of stuff, title case. This one's really helpful, is null or white space. This is really, really common. Do you ever do that thing where you kind of say, if my string variable equals, and then you just do 2 quotation marks? Well, you know, does that really cover you for your null case or just a blank white space? You know, it gets a bit confusing. So null or white space, really, really helpful. Transform extensions, get scene hierarchy path. This one is great. It's especially useful if you're doing serialization of scenes outside of Unity's serialization system, which is something I think we do fairly often when we're doing kind of save game systems. So get scene hierarchy path, you can give it a transform and it will effectively give you back the path to that transform relative to your scene root. So if you're looking at the, I don't know, cat's whiskers, then it would return to you cats/cat7/head/whisker, and you know, it's kind of the full transform path to it, assuming obviously that is your path to that, that transform. Vector2 extensions. Well, going to a vector2 int is incredibly useful. I don't know why we don't just have a constructor on vector2 int that takes in a vector2, or at least takes in floats and rounds them down. It's actually quite annoying. Is nan, has nan, clamping, within ranges is approximately something. To angle rad and to angle deg, I mean, they're obviously quite helpful. It's just an atan2 operation, but nevertheless, it can be useful. And then with X and with Y, this kind of with notation is super useful. Vector3 extensions basically contains all the same stuff, just in 3 dimensions. That's great. So those are the extensions that we use, and they come up quite a lot. Not to jump around too much, but I just want to quickly make a quick note. When I was in base behavior, you may have seen right at the top, we were in namespace Digital Salmon. Digital Salmon obviously being our company name, and all of the other bits in the core library are within the Digital Salmon namespace, or are they called sub namespaces? I'm not really sure, but Digital Salmon dot a part of it. The only one that I can think of right now that specifically needed its own namespace, and this is something I would recommend, is extensions. Namespace digitalsalmon.extensions. I think it's really useful to use extension methods, but I think it's really useful to understand when you're using extension methods. You shouldn't be using them and thinking that they're part of the native type, because that's you not fully understanding the type that you're working on. So if I call render texture .toTexture2D, I should be aware of the fact that that's my code doing the conversion. It's not something that's natively included, even if it should be included. And then if something's going wrong, I'm not looking at my code and saying, well, I'm doing this right, because no, I may have made a mistake. If I wrote that part of the library, then it could be a mistake on my end. Cool. So I'm not going to touch on settings because it's a really, really big system. We may get into it in a later video if people kind of like the way this is going. So this is cool. Protected singleton. Again, it's not something that we sort of claim any ownership over. This is a very kind of common thing. I know there's a lot of discussion on the internet, singletons, bad, good. I mean, mostly the discussion is saying bad, but yeah, they can be useful. Whether you like them or not, they can be useful. So in our case, same thing, lazy loaded. We're not doing any of the thread locking stuff because we don't tend to do much async work. Get new instance is, let's have a look what we're doing here. Get new instance, right, cool. So it's a generic type, protected singleton T. So I would say public class UI controller extends protected singleton of type UI controller. And that way, when I find the type will be UI controller. I'll try and look for one in the scene. If there is one, I'll destroy if there's more than one. And if there's exactly one, I'll return it. If not, I'll create a new game object, name it the name of the type. There you go, there's an example, camel to title case. That's very nice. And then I will add the component to it and then store it in my backing field. As well as that, I call onInstanceCreated, which is a virtual method right here. So I can override that, and I can, a bit like start and awake is good for initialization. Sometimes it's useful to know, I've just been created. I think that will be called after the awake and probably even after the start, but nevertheless, it can be useful. But this is a protected singleton. So what that means is the instance is protected. And it's kind of hard to give you guys a use case for that without showing you a couple of bits of it that I'm not really want to get into yet. But what we do is for our regular singleton, which we just call singleton, is we create a new instance of T called instance, which is of course also static, so it can be referenced. And we just grab the instance of our base class. And what that means is we've effectively unprotected. We've now publicized our instance without having to write the entire class again. We're still all the same logic as protected singleton. This is probably the one that we use more often in kind of gameplay. I say often, we don't particularly use singletons, but on the off chance that it makes sense, this is the one we tend to use. Protected singleton has other use cases where you have an internal system that relies on a particular singleton, but it's the only system you want to be speaking to that singleton. And the argument for using the singleton over statics in this case is mostly that the singleton exists as a component and therefore has access to all kinds of, you see it's a base behavior, therefore it's a mono behavior, has access to things like start coroutine and other bits and bobs that exist only on a mono behavior. Okay, that's the singleton. Right, systems. Okay, for systems, some of these are worth talking about, some of them kind of a little bit more internal. Okay, so easing property. Here we have the easing library. It's the same one that is in jQuery and is in hundreds of other languages. It was written by people much smarter than us. I wish I could give credit. Credit should really be in the source file here, but they're fairly well-known equations. And in our case, we've got the full equation with B, C, and D. Which I believe are the ranges and the overall sort of time for the interpolation. But the one that we really just use is T. So we'll just say linear T, ease in T. And these get used in all kinds of places. We can talk a little bit more about that shortly. If you're using something like .tween or lean_tween or any of the other tweening libraries, they've probably got these in them. And obviously there's always animation curves as well for getting nice easing. But since we don't have unlocked handles yet, although I think we're getting them, you can't do a lot of these using an animation curve. The kind of powerhouse behind the easing, or sorry, the easing is the powerhouse behind the type, is easing property. What easing property does is it's a serializable class. The only bit that really gets stored is the function index and the function name. And it has an evaluate method. Okay, and so what you would do, in fact, let's do a quick example, is in Unity, I would create a new type. And in my own type, I'm going to declare this easing property just so I can show you guys what it would look like. And then I'm going to attach this new easing to here. And you'll see I get a drop down for each of those types. I can call, for instance, cubic. And then looking back at my code, if in a method I want to access that easing, I'm a far better typer than I appear, but we're over the top of a box. I can call evaluate, and I can pass in a 0 to 1 range, and it's going to give me back the easing curve. The easing property is effectively powered by one of the editors. So if I go to systems easing property in the property drawer, and it just uses a little bit of editor code to make sure you get that drop down. And it uses, just for the sake of running through it quickly, it does use reflection to take a look at all the methods that exist on the type of easing, which have 4 parameters, and where all the parameters are floats, and it basically creates a delegate for it, and then that sort of gets stored as a function. I don't need to go too much into detail, but basically having access to those easing properties, especially in the inspector, is super useful to making really juicy animations without really needing to use the animation system. Okay, pooling. We have an object pool. That's really, really common. It's a really, really common pattern. You guys have probably seen this code 100 times. Standard stuff. It stores a bunch of objects that can be pushed and pulled from the pool and be reused. It seems like Unity is going in a direction where this isn't going to be quite so necessary anymore, as instantiation is going to be getting a lot cheaper. But for now, again, object pooling really useful. We have a dynamic pool. This one's really useful. So our dynamic pool is a dynamic pool generic type T, where T inherits from component and iPooled object. We use an interface-based object pool. Most people would probably use an object-based one where they knew it was going to be a monobehavior, but we wanted to be able to pool objects that weren't necessarily monobehaviors, so we use an interface for it. But the dynamic pool effectively creates a pool for any object where you give it a template. So if I pass in a particular template and it doesn't have that template stored in its dictionary of templates to object pools, it will create an object pool for it. So as an example, I could create a dynamic pool of type enemy, and then I would say get from template, and I'd pass in an archer, say the prefab, which I've loaded from resources, and it would say, okay, well, I don't have an object pool for archers. So in the dictionary, let's key in using archer as the key and make an object pool of the archer. And then it would give me back something from that object pool. And what that means is I don't have to make object pool for archer, object pool for barbarian, object pool for warrior. I just make an object pool for enemy, which is the parent class, and it contains all of the pools, which can also be really nice. If I wanted to know how many enemies are in the game, this guy could probably just keep track, or he could sort of aggregate all of his pools and say, well, there are 76 active objects or whatever else it might be. And that has things like scene manager sort of clearing itself at the end, just in case it's not a managed object. Also, it has overrides for things like how to create an object, because iPooled object isn't necessarily a monobehavior, so its creation needs to be managed kind of quite carefully. And the nice thing is this object pool creates an object in the scene called the name of that thing with dynamic pool, and then all of the objects that it spawns get created underneath it. It basically just keeps everything really organized. Just to show you the iPooled object interface, it's a bunch of methods that can be called and an action that can be called when it's ready to go back into the pool. Screen tint, this is something we use quite a lot. This is a slightly older version. The newest version is in a package we've released called Fade, which will be on the Unity Asset Store very soon. It's also on the Epic Marketplace in a slightly different flavor. But it's effectively exposing 3 different methods which we use quite a lot, which is dip, fade, and I guess instant fade in this case. Dip will dip the screen to in this case black, and then come back up, and fade will just fade to a given alpha. But as an example, because we have these on midpoint and on complete actions, you can call dip, say 1 as 1 second, and then the on midpoint could be hide something in the scene or change something about the scene. One of the packages we have on the asset store is called Complete 360 Tour, and it's used to make virtual tours, and this screen tint exists within it. And what we do is when someone looks at a hotspot and the hotspot's activated, we dip down to black. On the midpoint of black, we switch our media to a different part of the virtual tour, and then it'll come back up. There's also the on complete, which I think is actually, in the case of the virtual tour, used to then show the hotspots once we're back up from black. It's a really, really easy system. Basically, you just need a simple shader, and then you override it's not an override because it's Unity's magic, but you use the on render image method and just blip. This is about as basic as a screen effect can go. In this case, we have this tint property, and if anything sets it, so if any of the coroutines are changing the tint and fiddling with its alpha, we update the material property, and that just sets a particular property on the material which we are currently blitting. Works in editor, works at runtime. I think we have a sort of an updated version of this in Fade, which I now need to pull back into the core libraries, but it kind of does the job. One of the biggest systems that we use in this is UI. We have effectively an entire UI system. It gets quite complicated. I don't want to go too far into it. I'll show you what it ends up looking like. When you have the core libraries in, if I open up some of our various editor windows, you'll see that there's a fairly sort of consistent look amongst them. They sort of all share the same button with nice rounded corners and sort of similar fonts and things. This is all because our UI system is driven by the same different bits. And they also work at runtime, which is nice. So if I open up the UI system, some of the most important ones are effectively we separate different aspects of our UI into panels. A panel will have a title, subtitle, description. It'll know if it's displaying, and it'll have virtual methods for enable, disable, initialize, focus, and so on. And when you create an editor window, those methods will be called by the editor window to ensure that they kind of get handed down. And if you have any sub panels, so if an editor panel contains an editor panel, it passes them down to its children. So everyone gets these events. Right, so an editor panel, and then we have a simple editor panel, which is a type of editor panel, which just contains some of the GUI bits for drawing headers and toolbars and things. And that's why most of the UI panels that we do all look pretty similar, because they're displaying the header in exactly the same way. And in the case of, for instance, the header, what it's doing is taking the subtitle, title, and description, title, subtitle, description, and drawing them using a particular style. One step lower than that, we have a stateful editor panel, which is a type simple editor panel. So we're moving down the hierarchy. That takes in an object, which is then serialized and dealt with so that we can effectively maintain state. So that, for instance, when you click play mode or when you restart the editor, your editor panels are in the same state they were in before. That gets pretty deep. Something that is incredibly useful is managing GUI styles without specifically defining them as a sort of a scriptable object or in some kind of massive library. We like to do a lot of that in code. Everything here is lazy loaded, so you obviously you pay for the code size, but if you don't use the style, you don't pay for it. So especially at runtime, this gets very, very cheap. And we've broken down our style system into a bunch of different pieces. This contains just sort of a mismatch of various different bits and bobs, but some of the great ones are, style box. So again, it's something we can get into later if people are interested, but we have a style group system that lets us define styles by making variants of existing styles. So in this case, we have a flat dark gray, flat darkish, and you'll notice darkish gray matches the name of the colors in the colors class. In fact, you can see that here using colors.darkishgray. So if I needed a particular GUI style that was just a flat box with a fixed color, for instance, I could very easily just copy this, change a couple bits in it, and here you go, using the with alpha, it's a good example, and it would be ready to go. So that's for box. We also have buttons, and these contain a bunch of nice sort of rounded buttons or squared off buttons or whatever it might be. And again, we're using that same pattern. Fonts, Again, just like we have style group, we have font group. For instance, in this case, a font group, in fact, this is the font group class, isn't it? Font group, we have, inside it, we have a default, and that just returns you 3 fonts, standard, light, and bold. And that's used by our style system so that when we say label, label bold, label light, it gives us the sort of correct font back. And then in this case, we have an override of font group, a subclass, which overrides those 3 fonts to load up Roboto, which is the one we tend to use in our UI system. We have GUI. GUI contains a bunch of methods. GUI is broken down into style.GUI and, if I scroll all the way down, style.GUI layout. And these are our GUI and GUI layout functions. The definition being that a GUI function requires a Rect and a GUI layout is auto layouted. There's sort of a whole deep rabbit hole about using GUI versus GUI layout and when to use which and things. Don't really want to get into that, but basically it's just for sort of drawing a large button or a drop down or various other kind of utility methods. We have text. It's going to look a little bit like box and a little bit like fonts and all the others, so it contains different text. So I could go style.text.small-label or style.text.small-label centered, and there's kind of all the different variants, and since it's all lazy loaded, you won't pay for it unless you use it. So we can really fill these libraries out. Textures. This one is really helpful for generating things like those rounded buttons, and we've got shaders that kind of power them. Generating a flat texture. Blending textures, this one is really helpful. So you can take a base texture and draw something over the top of it, and then kind of bake that down to a texture using a given Rect area. So if I open up Unity, you'll see here, my tick boxes are a nice little rounded box with a tick in them. Well, that's just me taking this tick icon, which actually is in here. Here's my tick. And at runtime, or I suppose at editor time, but it's effectively running code, I'm baking that tick into that procedural rounded box and then assigning it to the correct style. Rounded box texture, normal box texture, temporary render texture, that kind of stuff. The style group system is here. It's basically a big copy of the Unity GUI style system with a couple of extra bits. It sort of keys out background textures so it doesn't generate them too much, and it has this kind of like set font, set color, set weight kind of system to it. So it's effectively just extending GUI style, and then when you're kind of ready to use it, you can ask for its GUI style and it will either generate one or give you back the one that you asked for. Sorry, here, create or get style. So if I ask for its style, it will create or get one, and if it's dirty, it'll regenerate it, and if it's not, it'll just give it back. So that, again, that's pretty cheap. So effectively, when you draw up these big stacks, I'm saying instance, I'm giving the name of this particular GUI style, and that's being used in a dictionary to key out this instance, setting a bunch of settings on it and calling style. So the very first frame that I ask for that, it will create the style, key it using the key name small bold label, and then the next time I ask for it .style, rather than creating a new one, it will get it from the dictionary. And that means you basically pay for it once and it's ready to go. There is one small word of warning, which is this does get more expensive if you use a whole bunch of them because you're having to do a dictionary lookup. I'm pretty sure a dictionary lookup is sort of done in linear time, so it's not crazy, but yeah, you do pay. The more you've got, the more you pay. But there's no allocations or anything every frame, so it's, it really is kind of okay. That's kind of it for the style system as far as this goes. One thing that's kind of quite important but quite easy to miss is that the whole thing is in a non-editor namespace. Okay, there's no editor code going on here. GUI style isn't an editor type. So these editor panels and all this kind of stuff, they can exist in non-editor namespaces, which is very useful. So for instance, our settings system, you'll see there's a sort of settings window here. Yeah, okay, it's a game window, sure. But if I add a settings inspector component and I press play and I shift S, you'll see that actually I've got a runtime version of that editor window. And that's because every part of this editor panel exists outside of the editor namespace. The only part of this that exists in the editor namespace is the editor window itself. And the window simply serves to draw the panel. Okay, it's a deep system. I don't know how many people kind of get into this kind of stuff, so I don't know how helpful it is to go into detail, but yeah, it exists. It's pretty cool. We've got I/O, valid resources path, removing extension formatting, just IO extensions, fine. Usually used to check whether a given asset is a resource, so useful for serialization. Then there's wait. Again, I really don't want to take credit for wait. Wait is something that was introduced to me by the guys at Apache Interactive. What it effectively does is it caches out wait for seconds instances, class instances, so that you don't have to allocate a new wait for seconds every time you call it. So if I say wait.seconds and I give a certain number of seconds and I leave caching as true, then it checks a dictionary for a pre-existing wait rather than allocating a new one. I'm not entirely clear on how the wait for seconds system works and how some of that yielding happens, because two different things can yield the same wait for seconds object instance and seemingly do it sort of asynchronously. So you can kick one off, say a 5-second wait, and then a second later do another 5-second wait, and the first one will end, and then a second later the second one will. Sorry if it's a little hard to follow, but basically it's pretty clever. I don't know quite what's going on behind the scenes, but this class at least is fairly straightforward. It's also got a fixed end of frame and fixed update waits. So again, no more allocations, which is great. Okay. Types, limited size stack. This is cool. If you use stacks, this one has a limited size. It pops off the bottom if it pushes in the top. Great. I'm not going to get into that one. Binding flags. This is quite useful. Again, I think this was taken from someone else's libraries, but basically it's some very commonly used binding flags. If you're into reflection, this can kind of save a little bit of time. Event handlers. This is one I really recommend everyone does, which is have a bunch of delegates. In our case, we call them event handlers. We have ones for generics and we have ones for kind of commonly used types. And then we have an extension methods set for them, which is invoke safe. It's really, really common that you have to sort of say, if event is not equal to null, then invoke it. It's a strange pattern. I personally feel like the point of an event is that I can shout about it whether or not everyone's listening. But if no one's listening, you can throw a null reference exception. So we use invoke safe rather than invoke using these extension methods. It used to be if self is not equal to null invoke, but now we use the sort of self question mark, nice C#6 stuff. I mean, that's another thing to note actually. I'm totally out of step with where the video is, but Digital Salmon core libraries work in C#6, even if your Unity is running in .NET 3.5 or C#4. Yeah, C#4. If you're working in C#4, like that's fine, because the DLL is kind of working in its own little environment and it's still going to work. That being said, we do use C#6 in our Unity environment as well for most of the work we do. I mean, it's not fully supported and it's not fully stable, but we haven't really had any issues with it, so it's great. This is the instance handler we talked about earlier. Don't really want to go into it, but it just basically covers caching out and locating source materials and things like that. Operator, useful enum, comes up every so often, equality, inequality, less than, greater than, that kind of stuff. We have a noise class. I think, again, we did not write this. We did not invent simplex noise, but it's useful to have if we ever need to get some noise in C#. More often, we get our noise in shader because we're doing more kind of noise in shader work than we tend to do in C# work. But I don't know, if you were doing some kind of sort of procedural or some weighting or something, it might be useful. We had a class called vector2int. We've now put it into an obsolete namespace because Unity's got a native one. If anyone at Unity is watching, please put more into this class. It's awesome, but it could do with a couple of extra little bits. So I'm not sure exactly which ones it does and doesn't have, but for instance, we had a bunch of statics here for all the different directions, and 0 and 1 and -1, that was great. We had the cardinals and the ordinals as arrays. We had the major axis with square magnitude and magnitude. In hindsight, I'm not entirely sure that this entire part was actually made by us. I think this one may have come from the guys, somebody else's libraries. Again, I don't want to kind of take credit for this, but this is a massive one. Please give vector2int a constructor that takes in a vector2. I know that it's going to push it down to an int. I declared the type as int. It would be very helpful, and takes in floats. Currently, I think the only constructor Unity has is 2 ints, which is a little bit limiting. We got some operators for casting between vector2 and vector2int, and equality operators, and going to a vector2. This one was really helpful. It's not that I necessarily want to suddenly have floats in my XY values, but maybe I have something I want to put this into that only takes in a vector2. And since they're structs and we have no kind of hierarchy there, kind of casting between the two can get a bit annoying. The with X and with Y, just like before, with and with. lengths and distances and min and max and scales and clamps and that kind of stuff. Same thing for vector3int. Again, now it's obsolete, but vector4int does need to exist because Unity doesn't have it as a native type. Vector4int is, I can see why people might say, oh, you know, I'm never going to use that. But then consider the class Rect. Okay, Rect, which is used all the time in GUI systems, takes in 4 values. Now, I'm fairly confident some aspects of Rect can take in floats, which is actually quite annoying because we're working with pixels here. Sometimes, you know, you want to have an integer Rect, which a vector4int effectively is, and I think we might even have some casting. It may not be in this class between vector4int and Rect. That one should be added. The other one is we have a bunch of utilities. So I'm aware that this video is kind of going on and on and on, and we may kind of cut it into multiple little pieces. But the utilities are methods that pertain to particular aspects of code, but don't necessarily make sense as an extension method. So they'd just kind of be called flat out. So it would be color utilities dot, converting between C# colors, RGB colors, hex colors, that kind of stuff. Doesn't really make sense to put that into, you know, if you've got a string that says new color with RGB, you wouldn't want the string to have the extension method toColor. It wouldn't make any sense. We've got graphics utilities, draw on GUI layout sprite and draw on GUI sprite. I don't think the GUI system natively supports drawing sprites, it only draws textures. So we kind of pull a GUI draw using that. Cloning a texture, I'm not sure where we're using it, but I'm sure we are. Graphics utility scaling. Okay, yeah, this one came from a third party, but it contains point bilinear and I think trilinear scaling. Perhaps we took out trilinear. One thing, you know, I can think we could really do with adding to this is a bicubic scaling. We do have a bicubic scaling system, but it requires the use of the system drawing namespace, which at least used to cause a couple issues. I think it's kind of chilling out now, it's not so bad. Material utilities, this one's pretty useful for, okay, set material value from block and get a block value. I think we were using these in a bunch of our different custom shader inspectors. Couldn't tell you. But having shader property types as an enum, definitely useful. Math utilities, things that are effectively missing from the MathF libraries. I think modulus is one that they may now have, but if they don't, please, you know, be very, very useful. Point distance to line, that wasn't us, some Hermite stuff. Fracking, you know, fracking of a vector3, you know, maybe that's useful to you for some reason. Lots of these are coming from other people's libraries, so I wouldn't want to go into them. Sprite. Okay, we have a sprite utility, which one of the really useful ones is we can render a sprite group. So we return a sprite, which is the layering of a set of sprites by overlaying all of their anchors. This one was super useful for doing a 2D game that we were doing, where we had characters broken down so their eyes and their lips and their beard and their hat and whatever were all individual sprites. Now I can draw each of them as an individual sprite renderer or image or whatever other rendering system I've got, but I'm drawing individually. I'm getting, you know, if nothing else, I'm getting overdraw. And especially if I'm trying to deal with kind of pixelation issues and subpixel aliasing and things, then it's really helpful to kind of bake those sprites all into one. So I get one sprite, easy to work with, and that's the head of my character. And that's the kind of thing you might do after the custom character screen. So you might design your character, go to game, and when you enter the game, you would bake all your sprites down into a single one. Most of the code is up on screen. If you want it, take it, it's fine. Vector utilities, smooth step, friggin' best function in the world, square distance, min, max, clamping, that kind of stuff. Okay guys, that covers a kind of introduction to our core libraries. I hope you guys enjoyed the video. Sorry that it got a little bit long. There's a whole lot of stuff to cover and it's kind of easy to get rambling when you find things interesting. If you liked it, let us know, comment on Reddit, comment on YouTube. We'd love to hear back. Sweet.